Displacement. The first quantity in kinematics that we must familiarize with is displacement. And also, we have to differentiate its meaning from distance. To illustrate this one, let's consider this example. Let's say we have a car. Let's say this rectangle is our car. That is at initial time or at time 0 seconds, its position is 5 meter. Let's say 5 meter from a tree. After some times, it moved further to the right. At time t, now its position is, let's say, its now final position now is 10 meter. So now, what is the distance traveled by the car and what is displacement? So the distance traveled by the car is 5 meter. And the displacement, the symbol for distance is d. And the displacement is delta x. Is also equal to 5 meter. Or in formula, the formula for displacement is delta x, wherein delta means change and x is position, is equal to the difference of its position or the final distance or final position minus its initial position. So the initial position of the car is 5 meter, while the final position is 10 meter from the origin, which is 3. And using the formula, we can find or solve for the displacement as 10 minus 5, which equals to 5 meter. Now, let's consider another example. Let's say our origin is this tree, which is 0 meter, and we have this car. The car rectangle is resting at the initial position. So our initial time is at x naught or at origin, which is 0 meter. And after some times, it moves to the left at a distance of, let's say, 12 meter. Then it moves backward. Okay, or let's move to the left. Let's say it moved to the left. At a distance of, let's say, 6 meter. So now, what is the distance traveled by the car and what is displacement? Okay, so the distance traveled by the car is from its initial position, which is from 0, it moves to the right at 12 meter, then backward to the left at 6 meter. Therefore, the distance traveled by the car is 12 plus 6, which is equal to 18 meter. Now, what is the displacement of the car from initial time to its final position or final time? So the displacement based on the formula is final position minus initial position, wherein its final position is 6 meter from the left, uh, from the right of the tree, and its initial position is 0. Therefore, the displacement of the car is 6 meter. Can you see the difference between displacement and distance? Okay, now, let's consider another example. Let's say an object or a car start at let's say 2 meter from from the origin. Then it moves to the left. Okay, let's say that. At a distance of, let's say, 5 meter. So starting from 2 meter from the right of the origin, it moves to the left at 5 meter from its original position. So the distance traveled by the object or the car is 5 meter. So now, what is the displacement? So displacement, again, from initial position up or from its initial position to the final position. Therefore, our displacement is, its final position is 3 meter from the origin minus its initial position, which is 2 meter. But take note, 3 meter from the origin is negative 3. Since its direction is to the left. Minus 2 meter, therefore our displacement is negative 5 meter. So we have to take note of this. Distance is a scalar quantity. While displacement is a vector quantity. So in terms of a scalar quantity, we can add algebraically the magnitude, while in vector we have to add its magnitude vectorially, or we have to consider its direction. So take note that in displacement, direction is very important. As we can see in our third illustration, our displacement is -5. Why? Because negative means it's opposite of our positive direction that we have set. And in this case, using the line number to the right is positive, while going to the left is negative. Therefore, using this convention, our displacement is going to the left, which is negative direction. And the magnitude from its initial position to its final position, the change in position is 5 meter. Okay, so let's have another example. Suppose you are going to a store which is located 3 meter, or let's say 4 meter to the west, 4 meter west, and 3 meter north. So what is the distance and what is the displacement? So the distance is 3 plus 4 is 7 meter, while displacement from its initial position to its final position is this one, represented by the red arrow. So using Pythagorean theorem, we can solve that the displacement from initial position to its final position is 5 meter. Again, to conclude this one, displacement and distance is a scalar quantity, while displacement is a vector quantity. Meaning, with distance as a scalar quantity, it is the sum or the total length traveled by an object. So we're just going to add all the distance it traveled, while displacement is the change of its position. And we can solve for displacement using the formula delta x is equal to final position and minus initial position. And take note, since it is a vector quantity, direction is important. So in our last illustration or fourth illustration, its direction is this one, represented by theta. And using trigonometric function of inverse, let's say arctangent, we can solve for theta. So that's all for displacement and distance. Now, let's check your understanding. Try to solve this problem. A honeybee leaves the hive and travels a distance of 2 kilometers before returning to the hive. What is the distance traveled by the bee? What is the magnitude of the displacement vector of the bee? So comment down your answer in the comment section.